Why data node here? S3 and 1. Wait. So in the place of name node, you started data node. Okay, so from data node. And you started only one general node. Okay, where is the document? $185 is not working. Only 4 nodes you have taken, huh? Madam, you there? One second, madam, don't control. How many name nodes you have? Yeah, madam.
Yes. Sir. Hello.
How many name nodes you have?
Sir, 3 name nodes, sir.
But I can see name node here and like a failover controller here. Okay. Madam, okay. Yeah.
Okay.
You should modify like this, madam, actually.
So instead of multiples, we can create a single one.
No. Okay.
So,
Every time, okay, when you are changing, okay, you need to change it in such a way that, okay, so here, okay, you are taking 4 name nodes. Okay.
yes, sir.
Okay, 3 general nodes.
General nodes, Zookeeper, data nodes.
Only 2 data nodes.
Yes, sir.
Okay. These are Hadoop nodes. 185 is not there. Yes, this is correct. Okay.
Yes, sir.
To remove the previous ones actually. Okay, so okay, good. Nothing is there. Now you can start one by one. Now let's see the status. One failure controller is not working actually. Okay, in this.
మనకి ఎలా తెలుస్తుంది సార్ వర్క్ అవ్వట్లేదని?
అక్కడ ఉంది కదా మేడం, ఇక్కడ లేదు కదా. ఇప్పుడు ఫెయిల్యూర్ కంట్రోల్ 3 చోట్ల ఉంది. ఇక్కడ
ఓకే సార్, ఫస్ట్ వన్ 180.
You need to execute this command once.
Okay, sir.
Format it gives. (183) with exit code. (183) now also it is showing some exit code.
Yes, sir.
But however, it started now. Yeah? 184 name node is not there. Now your cluster started properly. Okay, we have 3 zookeepers, okay, 4 failure controllers, 4 name nodes, 2 data nodes, okay, 3 journal nodes. Yes. Okay, so now okay, DFS 7 plus root. Madam, I feel okay, so you are not done the configuration properly.
Configuration, sir. Okay, sir. I will do once again, sir.
Yeah. Please. Okay, so let's not waste time. Okay.
Okay.
So check the
Okay, sir.
configuration. Yeah. Okay. Yeah. Okay. Yes, I'm sharing my screen. Okay. So okay, guys. Okay. So yesterday we were talking about HBase, and okay, we have seen all the concepts in HBase. So any questions on HBase part, guys? Okay. No questions on HBase. Okay. So the next tool okay, we have in our list is Flume. Okay. Let me open this explanation document. Okay. So the next tool in our list is okay, Flume. What is this Flume actually? What is this Flume? So normally, okay. Flume is again an open source Apache project and initially developed by Cloudera. Okay, so who invented this tool? Initially developed by Cloudera. Okay, but okay, the same tool is being used in all other versions also. Cloudera, Hortonworks, Mapper, and new Cloudera also. But you know what they did actually? Okay, so now Hortonworks team okay removed this tool. Okay, so in the latest versions, remove this tool. Okay, so they are telling that okay, we don't support this tool in the latest versions. Okay, anyway, Hortonworks itself is not there right now. Okay, so nothing to worry about that. Okay, but okay, so here this is there for old version. STP 2.7. Okay, but okay, we are seeing okay, 3 point something right 3.1. Okay, we are saying that is the reason okay, it is not there. So I'm showing you Flume in Cloudera. Okay. First of all, okay, let us add this tool okay, to Cloudera. Okay, so this is the cluster. Okay, I'm going to add Flume tool. Okay, add service here. And okay, I will say Flume. Okay, click on next. Okay, assign roles where you want to add a Flume. Okay, let's say I will add Flume. Okay, maybe I'll install in one machine itself. Okay, so one is fine. Okay, continue. Okay, click on finish. Okay, so now the Flume is added. Where is Flume? Okay, so this is the Flume tool. Okay, so now okay, let us start this service, Flume service. Okay, so it's very simple service okay, where you can add okay with next I mean by pressing next. Okay, and again okay, if you see Flume, okay, if you see the Flume, okay, so where okay, Flume will be installed in real-time clusters. Okay, so if I take this as a Hadoop cluster, okay, so now okay, Flume will be installed on edge nodes. Understood? Again, will be installed on edge nodes only. Okay, so as a Hadoop admin, okay, you should be knowing what service to be installed in what machine. Okay, so you have different areas here. Okay, this is the Hadoop area, this is the edge node area, this is the UI area. Okay, so okay, so what should be installed where? That is, I mean, you should understand that first actually. Okay. Flume is a tool which we will be installing on edge nodes only. Okay, so what is this Flume tool? What it does actually? So initially developed it by Cloudera. Okay, Okay, it is a distributed, reliable, available service for efficiently moving large amount of data as it is produced. What does it mean, guys? As it is produced. What do you mean of as it is produced? Okay. So as of now, what we have seen, okay, so we have seen Reliance Fresh here. Reliance Fresh. Okay, so Reliance Fresh will have billing machines here. Billing machines. Okay. So any customer comes here. So customer will buy the items. Okay, and they go to the billing machine. Okay, billing counter. So the person, I mean, the salesperson will complete your billing. Once they generate the bill, the data will go inside RDBMS. Okay, inside Reliance Fresh TV. Okay, this is Reliance Fresh TV database. Okay, Reliance Fresh database. Okay. Okay, Reliance Fresh database. Okay, so like this, okay, this is the same scenario for multiple cases actually. Okay. Okay, so here, okay, so what we are doing, okay, using scope, we are extracting this data and putting it into SDFS. This is what we are doing, correct? Okay, if I take this as SDFS, okay, SDFS, okay, we are extracting data from these RDBMSs, and okay, we are putting into SDFS. Okay, will you agree with me? This is what we are doing all these days. Okay, but how frequently this data is going here? How frequently the data is going from RDBMS to SDFS? Tell me. Okay, so this data is getting copied. Okay, so here, okay, so data from here to here, okay, mostly after night 11 o'clock, after all the stores are closed. Okay, maybe after 12 o'clock, okay, whatever the data we have in the Reliance Plus TVs, okay, it is getting copied using Scoop. Okay, it is getting copied to SDFX. Yes or no? Okay, so it means, okay, so here suppose today, okay, today, okay, let us take yesterday's data. Okay, so yesterday's data, okay, 418. Okay, so they'll open the shops by, let's say, 8 o'clock. Reliance Plus stores will open by 8 a.m. 8 o'clock to, okay, okay, they keep it open till 10:30 or 10 p.m. Understand, guys? Okay, 8 a.m. to 10 p.m. Okay, so this is the okay, so if this is the date, if this is the date, when this data will come and sit inside HDFS. This is the date, okay, when this data will come. Whatever the transaction happening between, okay, 8 a.m. April 18, 8 a.m. to 10 p.m., those transactions will come on. Okay, so this is 18, right? Those transactions will come, okay, to HDFS on, okay, either 418, okay, 418, 20, 22, okay, 11 p.m. Will you agree with me? 11 p.m. Okay, so okay, to be safer side, okay, so I would say, so night 12 a.m. This is better, right? That means, okay, whatever the transactions we have, okay, in this billing machine, in this RDBMS, all those transactions will be brought to SDFS, okay, on at night 12 o'clock, the day night 12 o'clock. Okay, so this is the same case for every day, right? So it means, okay, if Venkata goes to Reliance Fresh store at morning 10 o'clock and okay, he buy 2 items, okay, those 2 transactions, okay, will go to SDFS only, okay, that day night 12 o'clock, after 12 o'clock. Correct or not? Correct or not, guys? Okay, this
Yes,
is
sir.
called batch processing. This is called batch processing. Okay, but now, okay, now, okay, we have something called, okay, so this is a distributed, reliable, available service for efficiently moving large amount of data as it is produced. Okay, I want to move the data as it is produced. It means, okay, as it is generated, okay, I want to move the data from source to destination. Okay, understand? Okay, but what kind of data here? What kind of data? Okay, so normally, okay, yes, okay, so for Flumook, I will have to show some gaming examples. Then only you will understand better. Okay, so guys, so we all know online games, right? You all know online games. How
Yes.
many of you know Rummy Circle? How many of you know Rummy Circle? Okay, let us take, okay, this, okay, so there is a, okay, this is the server. Okay, okay, this is my server. This is my server. Inside this one, okay, so we have, okay, Rummy Circle software. Okay, okay, app, and here you have something called like a web server. Okay. Using web server, okay, so this Rummy Circle app will be, okay, will be accessed over internet. Okay, so now, okay, if I open, okay, rummycircle.com. Okay, so I can see this page. Okay, I can see this page. Okay, but okay, from where this page is coming, guys? This application is hosted from where? Okay, let's say this application, okay, is hosted in Delhi. Okay, I'm sitting and accessing this application, okay, from Bangalore. So this is Bangalore. Okay, calling this, okay, so this website, okay, www.ramesar.com. So this is the website. Okay, so if Venkata, okay, open this Chrome and okay, type, okay, www.ramesarcle.com. Okay, immediately, okay, this Chrome will connect to, okay, so will connect to this website and get the, I mean, get the pages actually. Okay, so this is the page. This is the page of what we have. Here is. Okay, so now, okay, it is asking for some username and password. Okay, so now, okay, I will log in with my username and password. Okay, click on verify. Okay, now I'm able to log into this website. Okay, so here, okay, it is saying that, okay, how many players are online here? How many players it is showing? 251,000. Some players it is showing online. Okay, now the question is that, is it a live data or yesterday's data?
Live data, sir.
Huh?
Live.
This is live data. Okay, so normally what happened? Okay, so now from Chrome, okay, I access this Circle website. Okay, then it opened the page, login page. Okay, I've entered my username and password. Okay, when I entered my username and password, okay, so then what this, okay, web server will do? Okay, so this web server will have a log here actually. So web server will have a log. Okay. So now, whenever a Venkata provide a valid user ID and password, immediately what this website will do, okay, website will record that in the log actually, saying that, okay, what it will say, okay, so user, okay, Venkata 1882, okay, has logged in successfully. Okay, so it will write, okay, an entry in the log. This is the log actually. Okay, understood, guys? See, okay, this is the log. Okay, every website will have a log. Otherwise, how to track, okay, if there is an issue with the website? So every website, okay, will have a log. Okay, so whenever Venkata log into this website, okay, using valid user ID and password, immediately to write that entry in this entry. Okay, now let's say I'm adding some cash. Add cash. Okay, let's say I'm adding 2000 rupees. Okay, so immediately once my transaction is successful, user Venkata has made payment of 2000 rupees. Okay, successfully. Okay, user Venkata, okay, has played, okay. Okay, so what are the different games that we have? Points from me, 101. 101. Okay. Okay, so it's not played, okay, has one. Okay, 200 rupees. 200. Okay. So then, okay, user web. Okay. Venkata has withdrawn 1000 rupees. Okay. User Venkata 1832 logged out. Okay. So every user okay, I mean, okay, every action is getting recorded here. Okay, when Venkata login, okay, so there's an entry in the log. Okay, when, okay, Venkata made payment, okay, it is writing here. Okay, so now how this application, okay, so okay, this website is showing that, okay, how many active players, okay, we have, maybe by using this log, right? Yes or no? Okay, so this is the log okay, where, okay, I mean, which is the source for these people, okay, to tell, okay, these many people are online today. Okay, and this number will be keep on changing. Okay, as more and more players log in, okay, this number will be keep on changing. Correct or not? Correct or not, guys? Okay, so this is how, okay, so the entries are coming in the log. Okay, this is the game data. Yes or no? So this is, okay, game data. Okay. Now the requirement is that I want to extract this game data. So what is the end for this log, guys? When is the end for this log? Tell me.
Logged out.
Huh? When is the end? Okay. When this log will be, okay, stopped?
Once the user logged out, sir.
Huh? When this log, okay, game data in the log will be stopped. Huh? If nobody is using this application, then only no data will be printed here. Okay. If more and more people are logging in, logging out, okay, so and okay, playing the games, okay, so every time they do this operation, okay, so this log will be keep on growing. Correct? Suppose, okay, so like Reliance Fresh, okay, so if you have any stop time, okay, then fine. Okay, so for Reliance Fresh, okay, we have, okay, the store will start by 8 o'clock, 8 a.m. and, okay, store will be closed by 10 p.m. every day. Okay, after 10 p.m. anytime I can take the data. Okay, so after 10 p.m. okay, I'm sure that there won't be any data in Reliance Fresh database. Correct? For that day. Okay, but is it the case here? Even if you see at night 12 o'clock, okay, 1 o'clock, okay, or at night 11 o'clock, 12 o'clock, 1 o'clock, also you will see so many players playing the games. It means, okay, this is a never-ending process. Yes or no? Until unless the website is crashed, okay, this is a never-ending process. Okay, you open, okay, Rummy Circle anytime, okay, anytime in the day or anytime in the night, okay, you will have at least, okay, so 1,000 players will be playing. Okay, so the log printing will be stopped only if you have only 0 players, or, okay, if website is crashed. Okay, so when there is no end, then, okay, when I will get this data into HDFS, I want to process this data. Okay, when I will get this data into SDFS? Tell me. When I should get this data into SDFS? If there is end, okay, so yes, okay. So this is the end, okay, so I will get it at night 12 o'clock. Okay, but for this there is no end. Okay, so the data will be keep on growing. Okay, so there is no end for your log. Okay, there's no end for your data. This data will be every second, okay, new lines will be entering into this log. Okay, but I want to extract this data. Okay, now I have a situation. Since there is no end time here, so I have to extract the rows, okay, as and when they generate. Okay, so whenever there is a new line in the log, I need to get that into HDFS. Okay, why I need this data? This is the data which will be helpful for me to generate some reports. Okay, what kind of reports I can generate here, guys? Can you tell me? From the log, can I generate any reports? Huh? Can I generate any reports from the log? Okay, normally if your data is like this, okay, generating reports is difficult. Okay, so we will see some examples, okay, how it works. Okay, okay, session 1. Okay, so here, okay, log into CN3 with, okay, user ID Alan. Okay, so log into, this is Cloudera, right? Cloudera CN3 with Alan. Okay, now log into CN3 with Alan. Okay, so the directory is already available. Okay, so I'm just deleting it. Okay, so create a new Flume agent file here. Okay, CN3 machine. Okay, I'm starting Flume. Okay, so this is the agent file. Okay, so looks like, okay, we need to have Flume, okay, on this machine also. Okay, I'm taking this like edge mode. Okay, it will work. Okay, so Flume will start, not a problem. Okay, so now, okay, so this is the Flume agent file, guys. Okay, so this is the Flume program. You take it like this. Okay, this is the Flume program. Okay, so now start Flume agent on CN3 machine. Okay. Okay. Yes. Okay, it started. Okay, so the Flume program has started now. Okay, I'll explain. Okay, what is this Flume program and everything I'll explain. Okay, so but okay, try to understand. Okay, session 2. Okay, log into CN3 with the user ID execute below. Okay, so okay, let us log into CN3 again. Okay, with Alan. One more session you take. CN3 Alan. Okay, so now I'm creating a file. Okay, okay, now session 3. Okay, again log into CN3 with Alan. Third session. So now, okay, try to understand, guys. Okay, see what I'm trying to do here. What I'm trying to do, I created a program here, guys. I created a program. Okay, the scoop programs are called as scoop agent. Flume programs are called as Flume agent programs actually. Okay, this is the agent program, okay, which I created. So here, okay, here I told, okay, so this is the source. What is source here? Okay, so forget about the source and all here. Okay, so here, okay, okay, let's start with source only. Okay, so what is the source here? Okay, for the Flume program, okay, so we will have a source. It means, okay, from where data will be generating. Okay, so the netcat collect is the source name. Okay, sync. Okay, what is sync? Okay, SDFS write is the sync. Okay, channel is memory channel. Okay, so these are the three names I'm giving actually. Agent source is this one, sync is this one, and channel is this one. Okay, so here, okay, so here netcat, source type is netcat. Okay, so from where, okay, I need to listen this one. I need to tell, okay, I need to tell where this source can be listened. Okay, the source will work from CN3 machine, okay, on this port number. Okay, now let us see this one on CN3 machine on this port number. What is running on CN3? So this is the port number.
Venkat, we installed it in CN4, yes?
No. Okay. Sir, okay. I created an agent. Okay, I created agent and I started this agent here. Okay, this agent, okay, will start listening this one. Understand? Okay, this is the source, and okay, destination equal to this is the path. Okay, now first let us see whether there is any data here. First of all.
So, sir, we installed it in two. Means you mean to say, agent is installed in CN3, but that Flume is installed in CN4, correct?
No. Okay, both are installed. Okay, so agent is just. I'm not touching CN4, sir. Forget about CN4. Am I using CN4 anywhere? No, right?
No, sir.
Okay.
So
Okay.
this is an example of this. What to say?
What I'm trying to do, I will tell you.
As node, yes, CN3 here.
Yeah, what I'm trying to do, I'll tell you. Okay. There is a file. What is the file name here? This is the file. What I'm trying to do, I'll tell you. This is the source actually. Okay. So now this is the log. Okay. So normally, okay, log. Okay. So this one. Okay. Entries will come and sit inside the log. Okay. Okay. This is the source. Okay. Now I'm using agent here. Okay. So this is the one. Okay. So whatever is there. Okay. You know what is netcat? What is netcat, guys? Can somebody tell me what is netcat? It will be reading from and writing network connections using TCP. Okay. Okay. It is a it's a networking utility. That's what they are saying. Okay. So now, okay. So this is the log. Okay. So let's say rumicircle.com. Okay. So it is writing the log into this one. Okay. So now, okay, what I'm doing using NC. Okay. Whatever is there in this log. Okay. I'm just doing netcat. Port number. Understood, sir?
Okay, sir.
Huh?
So it is reading this port basically.
Okay. So this is the log file. Okay. So now here, okay. So it's okay. This is also CN3. CN3.hadoop.com. Correct? Okay. Now I have Flume agent. Okay, which is a Flume program. Okay. So this Flume program, okay, where this Flume program is running. Okay. So this Flume program will start running on this one.
Okay, got it, sir. Yeah. This is running CN3 with this port number. Got it.
This port number. Okay. What this program will do? Okay, so this is the okay. So it is running here. The name of the program is this one. This is the program. Okay. Understand? This is the Flume agent program. This is the source. Okay. So now, what next? Okay. Now, this is the HDFS. This side, okay, so you have HDFS. Okay. So what is the path here? The HDFS path is this one. This is the path. Okay. So now, what the Flume agent will do? Okay. So there are two ways actually. Okay. One way is that, okay, you can tell Flume agent, okay, hey, this is the log. You go and get it. Okay. You go and get whatever is there inside this one. You get this one, okay, and put it here. Put it here. This is one way. Okay. So it means, okay, if there is line 1, okay, immediately you will have line 1 here. Okay. There is line 2. Line 2. Okay. Line 2 will come here immediately. Okay. There won't be any delay, guys. Understand? Okay. If there are, okay, 4 lines. Okay. So all 4 lines will come and sit here immediately. Okay. Because the agent is running continuously, monitoring this log file, and whatever is there, okay, whatever is there, it is taking and putting it here. Understood? Understood or not? Okay. So now, okay, let us push some log into this one. At this moment, okay, this is log. Okay, so this is empty log actually. Okay. So now I'm pushing one entry in the log here, guys. Okay. User Venkat has logged in successfully. Okay. So what I'm doing? Okay. So this is the first line I'm pushing. Okay. So this is the first line. Okay, I'm pushing. Okay. This is the first line in the log. Line 1. Okay. Since there is no application for us, okay, I'm adding this to this one. Added one line here. Okay. See here, can you see this one? Immediately it is creating a file on HDFS. Okay. Now, okay, let me add one more line here. This is the second line from here to here. So it means, okay, okay, it came here. Okay. Now this is third line. This is the fourth line. Okay. So like this, okay, like this, okay, I'll be okay. I'll put lines. Now you see, writing or not? Okay. We will do one thing. We'll go to HDFS and see. Okay. Our idea, okay, is that okay, the data will be in HDFS. Okay. So HDFS DFS -ls. Okay. DFS -ls project _rf data Flume. Okay. Can you see this one, guys? Okay. Is it the data? Huh? Is it the data? Where I'm putting the data, see, I'm inserting the data into this log, and I'm seeing this data in this place. Okay. Now, okay, we have second file. You see, there are 4 lines. Yes or no? Huh?
Yes.
Okay. Okay. Source log. How many entries are there? 4 entries are there. All 4 entries have come to HDFS or not?
Yes.
Okay. Yeah. Okay. The more and more entries you insert. Okay. So let's say I'm inserting these many entries now. Okay. So I'm inserting these many entries here.
So, sir, in Edge node, some application is writing some log, and those logs are
Not edge node, sir. Not only edge node. Okay, I'll tell you, sir. I'll tell you. Okay.
okay.
So now, okay, I did third one. Okay. And you see, even third one data also came. Okay. See, all the lines came. Third now. See, I'm inside. Okay, so here. Okay. This can be on any machine. Normally, source can be on any machine. So here you can see. So whatever is there in the log, okay, this is there. Okay. So normally source will be on any machine.
Okay, source can be on any machine, but
Anywhere. Okay.
flow from
Flow agent will be
mhm.
on edge node. Okay. Plume data. Now you see. Okay. Anywhere. Okay. Maybe okay. So this one. Okay. In this example, maybe okay. This log is in Delhi server. Okay. So here, okay, it's in Delhi. Okay. Think that okay, so, okay, sir. This Rummy Circle website is writing this log. Understood? Okay. Now tell me where is this log? It is in Delhi. Okay. Where is your edge node? It is in Mumbai. Okay. Where is your SDFS cluster? That's also in Mumbai.
So how will it communicate? SSH or?
Sir, okay, it should have connection, right? Okay. Otherwise, how it will communicate? Okay. So they should have valid connection between these two servers.
Okay.
From edge node and this source machine.
Is it through web server or sir? Basically.
Okay. Okay. So here, okay. Sir, okay, you can have okay, SSH also. Okay. But anyway, okay, all these servers are okay internally connected, na, sir.
That is correct, sir. But in Delhi, means in real time, if it is in Delhi, do we need to configure? Yes, how configuration part will be?
We need to tell that okay, what is the server name? Okay, what is the server name? What is the IP address? Or what is the log path? All this information we need to tell.
Okay,
in the agent configuration.
Got it. Sir.
See, in the agent configuration, you need to tell what is my source. In the agent configuration, you need to tell what is my destination. Okay. Understood?
Yes, sir, understood.
Okay, see here, the source information and destination information will be written in the agent configuration file.
Sir, here in the example, you're adding data, right? So it is CN3. It is on updating on edge node.
Okay. So just see, I cannot create any web server and one web application now. Okay. So that is the reason I have taken one log here, sir. Understood?
Yeah, I got it. But here, are you doing it on edge node or are you doing it on agent?
Think that this is edge node.
Okay, that is okay.
Yeah. Sir, okay, your source can be anywhere. Okay, my source can be in Delhi. My source can be in Mumbai. Okay, my source can be in Bangalore. My source can be in Chennai. Okay, or Hyderabad. Okay, anywhere. Okay, but my agents will be running on edge nodes, where okay, the cluster is located. Okay, HDFS.
So in this activity, you are doing it on edge node, right? Now,
Yes, sir. Because I don't have any other option.
Yes, I got it.
Clear. Okay.
Clear.
So here, okay, whatever data okay is getting printed in this log, okay, this agent will be continuously monitoring this log. Whenever there is a new entry here, immediately it will get that entry here. Understood? So there is no time lag also. Whatever is coming here, it will come here automatically. You got my point? Okay. So are we disturbing this rummy circle, this application or application log? We are not disturbing application and application log. Okay. So we are adding extra person here to take the new data and new lines and put it here. That's what we are doing here. Got it? Okay. So we'll see. Okay. So we'll come back to the theory point. Okay. So it's a distributed, reliable, available service for efficiently moving large amount of data as it is produced. That is what very important. Okay. That is the reason I made it color. Okay. Ideally suited for gathering logs from multiple systems and inserting them into STFS as they are generated. Okay. So mainly, okay. Suppose, okay, you take this example, guys. Okay. Suppose, okay, you have Reliance Fresh. How is your data, sir? What is your data in Reliance Fresh? Huh? Sir, please answer, sir. What is the data? Okay.
Billing
Transactions, billing transactions, correct? Okay.
Yeah.
How these transactions will be? It is okay. So what kind of data it is? It is structured data. Or not? Okay. So Reliance Fresh means okay, retail domain. Okay. Retail domain. Okay. So it's just structured data. Okay. Now I will take banking domain. What is major data in banking domain?
transactions.
Transactions only. It means okay, so structured data only. Okay. Okay. So it is structured data only. Okay. Then okay, you take healthcare domain. Okay. How your data will be? Of course, okay, it is structured data only. Okay. Okay. But okay, you take gaming domain. What is the data in gaming domain?
Unstructured, yes, sir. Unstructured.
Okay, we should not say unstructured. Okay, let us take okay, logs.
Ah, yes, kind of.
Logs. All your data will be in the logs. Okay. See, all your data, maybe because if you see, okay, banking domain, healthcare domain, Reliance, retail domain, and all, okay. So their data will be okay in the form of structured data, and okay, so those will be in some RDBMS. Or no? Okay. But here, okay, so when it comes to gaming domain, your data will be in the form of logs. Okay, so this what logs? Okay, I can say semi-structured data or unstructured, semi or unstructured data. Okay, so those are available in the form of logs. Okay, in servers, file servers. Yes or no? So gaming domain, okay, the data for gaming domain will be in the form of logs. Okay, and where these logs will be available? Okay, logs in application servers, majorly. Okay. So, okay, what I'm trying to say here, okay, not all domains data will be same. Okay, some domains. Okay, so let us take okay this one. Telecommunication, not telecommunication. Okay, what we say for TV, sir? Entertainment domain. Okay, I may not be 100% correct. Okay. How your data will be in entertainment domain?
Videos.
Yes or no?
Yes.
Okay. Just okay. This is the data. Okay, from entertainment domain. This is completely unstructured. This is completely structured data. Understand? Okay. So this one at least okay, we can call it as a semi-structured data. Understood? See, gaming domain, the data is different. Okay. For entertainment domain, the data is like okay, audios, videos, okay, pictures, messages. Okay. So these are the ones. Correct. Okay, so can we use suppose, okay, if the data is structured data, to extract the structured data from source and put into HDFS, you're using scoop. Yes or no? Yes or no?
Yes, sir.
Yes, sir.
Okay. If it is a gaming domain, okay, the data will be in the form of logs. Yes or no? Okay. So, and how these logs can be extracted? Okay. Can I use scoop to extract log data?
No.
I can't
No,
use
sir.
scoop to extract log data. What I need to use? I need to use
Flume.
Flume to extract log data. Okay. So now I have audios and videos. Okay. What tool I need to use? Will audios and videos can be brought by Flume? Flume is meant for logs. Okay. If I want to bring audios, videos and all, okay, so we need to see other tool, some other tools actually. Okay. Scoop cannot do this one, and okay, Flume cannot do this one, and okay, we need to see some other. Okay. Some other tools. Okay. What are those tools? Okay, we'll see in the later stage. Okay, so but at this moment you understood, right? Okay, so ideally suited for gathering logs from multiple systems and consider them into HDFS as they are generated. So this is the main use case of Flume. Okay, typically used to ingest log files from real-time systems such as web servers, firewalls, and sensor networks into HDFS. Okay, so what are these? Okay, web servers, firewalls, and all, guys. Huh?
Security.
You understood what is web server now? Okay, so maybe some web applications like that. Okay, firewall. Okay, now what is a firewall?
Security.
For security. Okay, let's say, okay, you have some servers like this case. Okay, so you have some servers like this. Server 1, server 2, okay, server 3, server 4. Okay, this is your company network. Okay, now, okay, so you kept a firewall, okay, on top of this one. So all these servers are safeguarded by firewall. Okay, now what this firewall will be doing? Okay, will firewall write a log or not? So whoever is passing through this firewall, whoever is okay. Suppose if anybody want to access any of the servers, okay, any of the servers inside this one, they have to pass through the firewall. Okay, so firewall will be writing a log actually here. The firewall will be writing a log saying that this is a firewall log. Okay, this is the log. Okay, what it will be writing? Okay, so who access? Okay, who access server 1? Who access server 2? Who accessed? Okay, suppose okay, if any user who any unauthorized user is trying to access, will it report that also or not?
Yes.
Huh?
Yes, sir. Yes.
Any unauthorized user is trying to access this one. Okay, yes, obviously it will report this one. Okay, so now let's say this is user Venkata, okay, authorized user. Okay, we know authorized user Ravi, not authorized user. Okay, so detected. Okay, unauthorized user Ravi trying to access server 1. Okay, it will write a log here. Yes or no? Okay. So if some unauthorized users are trying to access our servers, okay, if I get this alarm immediately, then okay, I can stop these people. Who knows? Okay, this guy may be a hacker, right? Huh?
Yes.
So here, okay, as and when there is a new entry in the log, okay, so I will take that and okay, I will check whether it is an unauthorized user or authorized user. If it is unauthorized user, so I will send an alarm saying that okay, so and so guy is trying to access our network firewall. Understood? Okay. So in this scenario, live data processing is important or not?
Yes, sir.
Real-time data processing. This one. This is say I cannot wait till evening to get this entry into HDFS. Then okay. So suppose okay, Ravi is trying to hack this firewall. Okay, morning 10 o'clock, and okay, there is an entry in the log. But if you take this log at evening 9 o'clock or at night 12 o'clock, what is the use? Is there any use? There is no use. Okay, so some data should be captured and processed immediately on the fly, on real-time basis. Okay, there should not be any delay. Okay, like Reliance Fresh here, there should not be any delay like this actually. Okay, so here, so I need to take immediate action. Okay, based on the entry in the log. Understood?
So how to understand whether it is a authorized user or not user for
that? They'll have some. Okay, so they'll have some firewall rules, right? Firewall rules. Okay, this only these people are there. This guy name is not there. Then he is unauthorized user. Correct.
Yes. And not any script is there.
Sir, firewall will have some firewall. Again, I need to teach you what is firewall. Okay, firewall will have some rules, sir. Okay, suppose whoever is crossing the firewall, it will check whether this guy is under allowed rules or not. This guy name is under allowed rules or not. If yes, then only it will allow you. Otherwise, it will stop you there.
Okay, sir, fine.
Okay, so it doesn't matter how it is identified, whether it is a unauthorized user or unauthorized user, but at the end of the day, it understood that this guy is unauthorized user. It printed a line in the log. Okay, so you have an entry in the log. Okay, now, so whenever there is an entry in the log, immediately you need to take an action. Yes or no? Okay, so I cannot process this data in the evening or night 12 o'clock. I have to process this data or this kind of data immediately on the fly. Okay, so in such requirements, Flume is very, very helpful. It gives a reliable solution that helps ingesting online streaming data from different source systems such as email messages, network traffic, log files, social media in HDFS. Okay, you take Twitter, guys. How your data will be in Twitter? What is the data in Twitter? What is the Twitter data? This structured data in Twitter. Okay, it's all tweets only. Okay, so is tweets are structured data? Definitely no.
No.
So these are unstructured data. Okay, but can I use unstructured, semi-structured data? So you can take it like unstructured only. Okay, so can I use Scoop to extract tweets? And again, when the tweets will be stopped? When Twitter will be stopped? Will Twitter stop?
No.
Or when Facebook will be stopped?
No.
Like Facebook also will say, hey guys, I work from morning 8 to night 10. Okay, after that, I'll be copying my data from source to HDFS. Is there anything like that? Okay, Facebook, Twitter will work 24/7. They work for 24/7, right? Okay, so for them there is no downtime. Okay, in such scenarios, yes, so we need to have these kind of tools. Okay, so all Twitter data will be extracted by using Flume. Okay. So for Twitter, without Flume, it's very difficult to handle their data. Okay, and currently in use in many large organizations, importing huge volumes of data produced by e-commerce websites like Flipkart, Amazon, networking sites like Twitter, Facebook, and all. Okay, so this is also one of the good tool. But suppose if you join a company, banking domain, will you see Flume? You may not see Flume because banking data may not be mostly banking data will not be like logs data. Banking data will be like structured data. Okay, so wherever is required, whoever is having a use case of Flume, they will use. Otherwise, no. Okay, so in our environment, we are not using Flume. Okay, so because we don't have any requirement to extract logs. That is the reason we are not using Flume. It doesn't mean that no other company also will not use. Okay, maybe there is a company where they don't have data, structured data, or they don't have RDBMS data. They have only tweets data. Okay, for them only They require only Flume. They don't require Scoop. Okay. What Hadoop is saying, okay, I will give you a set of tools, guys. Okay. Based on your requirement, okay, you use whatever, okay, you feel. Got my point?
Yes, sir.
Okay. So Hadoop is telling that, okay, I'll give you a set of tools. Okay, but okay, based on your requirement, okay, you use whatever you want. That's what Hadoop is saying. Okay. So now, okay, let's see Flume architecture. Okay, when I say Flume architecture, okay, each Flume agent has a source, sink, and channel. Okay, so this is the Flume architecture. Okay, so you will have a Flume. Okay, Flume program is called as a Flume agent actually. Okay, so each agent will have, okay, at least one source, at least one sink, and channel. Okay, so now what is the source? Okay, source means, okay, tells where the data, where to receive the data from. Okay, source means, okay, so from where I need to receive the data. What is sink? Okay, tells the node where to send the data to. Okay, so sink is the place, sink is the destination. Okay, where to put the data. So here, okay, if you see, okay, this is the data source. Okay, I want to take this data and put it into STFS. Sink is STFS here. Okay, and what is this channel? Okay, so when I say channel, it is a queue between source and sink to transfer the data. Okay, it is a path between your source and sink to transfer the data from source to sink. Okay, but there are different type of channels, guys. Okay, one is memory channel. What do you mean of memory channel? Okay, so when I say memory channel, okay, events are read from source into memory and passed to the sink. Okay, are faster in performance but lose data if agent is down. Okay, I'll give you one example, guys. Okay, memory channel. Okay, so this is the source. Okay, this is the agent, Flume agent. Okay, using memory channel. Using memory channel. Okay, this is the sink. Sink means destination. Okay, so now, okay, so what it does? Okay, what Flume agent will do? It will extract the data from source and put it into sink. Okay, so now we are using memory channel. Okay, okay, what will happen? Okay, so now agent is up and running. Agent is up. Okay, so now there is a line 1. Okay, so like this. Okay, 5 lines. Okay, so automatically all 5 lines will go to sink. Okay, but agent is down. Okay, but okay, we have some lines. Okay, but here, okay, agent is down. Agent is down. Okay, so when agent is down, whatever the logs you printed, okay, I mean, okay, the source has printed, okay, those will not come to destination. Okay, now you have line 10. Okay, agent is up. Okay, now you will have only line. Okay, so you understood. Memory channel means, okay, that the data between, okay, source and sink will travel through memory. Okay, since it is traveling through memory, okay, it is very fast. Memory channels are very fast because, okay, data is traveling through memory. Okay, and when it comes to sink, what is sink here? Okay, destination. Okay, but okay, what in case if agent is down, this program is down, what will happen? Okay, if agent is down, whatever the lines printed during that downtime, those lines will not be brought to STFS. Okay, when agent is up, okay, it is printing 10th line. Okay, so it will bring the new lines. Understood? So if you are using memory channels are very fast to transfer the data. But okay, only problem is that, okay, so when agent is down, okay, during that time, whatever the lines got printed in the log will not be brought to STFS. It means there may be some data loss. Understood? So this is memory channel. Okay. Now we have, okay, other channel. Okay. So file channel. What is this file channel? When it comes to file channel, okay, so what it will do, events are written into a file on disk first, then passed to sink. Okay. So if agent is up, okay, okay, what it will do first, okay, so whatever data is there, first, okay, it will write into it will write one copy here, guys. Agent is up. It will write one copy here. Okay. Agent is down. Okay. Now agent is back. Okay. When agent is back, it will compare. Okay. So this is okay. Staging area. What do you mean flume staging area? It means okay, whatever is there in so okay. In case of memory channel, whatever data we have, whatever lines we have in the source, automatically putting in the sink. In between, it is not storing anywhere. But when it comes to file channel, whatever is there in source, first it is writing into flume staging area from here. Okay, so this is the difference actually. This is the concept in memory channel, but when it comes to file channel, first it is coming here. From here it is going here. It means okay, in between it is writing in one place, correct? Okay, why it is writing in one place? Suppose okay, tomorrow flume agent down also, when it is back, okay, now it will check, okay, till what line I have extracted. So it will bring, okay, when it is up, okay, so it will bring, it will continue this one. So even though flume agent is down, there won't be any data loss here.
Sir, how to know agent is up and agent is down?
So agent is up means okay, it's agent program, sir. Okay, so here we started the program. Okay, yes, is it running or not? Okay, so Arc, if you still want to see, okay, so now you see, is it listening or not? This is what okay we have written, right?
Yes.
What is the program we have written? Okay, so here, okay, can you see this one? So starting, okay, created socket. Okay, what is this one? What is the channel here? Okay, what is the socket channel implementation? 114, this port number. This is the port number where your agent is running. Is it running here? This is the agent program. This is the agent program. GPS. Okay, can you see there is something called application? What is this application? What is this application, guys? Nothing but your flume program, flume agent. Got it? Okay. So file channel means okay, what file channel will do, instead of writing data directly into sink, first it will write in its own storage. Okay. Why it is writing in own storage? Okay, because okay, if tomorrow agent is down also, once agent is back, okay, it will check okay, till what line okay I extracted before it was down, then it will continue from there. It means okay, if you go with the file channel, there won't be any data loss. But here there is a data loss. Yes or no? Is there any data loss here? Huh? There's no data loss. Okay, but okay, file channels are slow because okay, they are writing in two places. First, it is writing in the staging area. From here, it is writing into sink. Okay, that is the reason file channels are very slow in performance. Okay, memory channels are directly writing the data from source to sink, so memory channels are very fast. But memory channels, okay, will not give you any guarantee if they are down.
Sir, it's a live data, right? So where is the data loss in memory channel, right?
Live data means okay, suppose agent is down. Okay, where is line 6, 7, 8, 9? Here.
So when it is up, it will copy paste, right?
When it is up, okay, it will continue from there.
Yeah, so there is no data loss here, sir.
I don't know. So, sir, okay, see here, is there any data loss?
There is no data loss in memory channel also.
Memory channel, there is a data loss, sir.
There is data loss.
Agent is down.
Where is line 6, 7, 8, 9? Sir, okay, see, in case of memory channel, when agent is up, that time, whatever the lines printed, only it will pick those lines.
That is the actual data, sir. Agent is up means the data will copy paste to the HDF.
Yes, sir. Yes, sir.
So agent is down means there is no data.
Sir, okay, agent is down. Does it mean, okay, here, okay, the source is my Rummy Circle website.
Yeah, not working.
Okay. Okay, let's say this is Facebook, sir. Source is my, okay, Facebook or Twitter. If I stop agent, okay, will they stop Facebook? Facebook also. Facebook will be producing the data, sir. This is Facebook data. Got it?
Okay.
Since your agent is stopped, okay, doesn't mean that, okay, source, okay, Facebook, okay, will stop there. Facebook also will stop producing data. Twitter also will stop its tweets. Correct?
Yes.
Okay. So my source, okay, so these lines are printed by these people. Okay, there's no, is agent printing these lines? No, right?
No, sir, no.
No, okay. So agent is just bringing the data generated by source.
Yeah, whatever data is there, it will copy paste into the HDF.
Yes. What are the tweets? Okay, it has, okay, when the agent is up, okay, so it will bring those tweets and put it into SDFS. Got it?
Okay. Got it.
Sir, in case high availability, is it possible?
Okay, we will come to that point. Okay. So clear right now? Okay. So memory channel and file channel. And okay, we have something called JDBC channel also. Okay. So events are stored in an embedded Derby database first and then passed to this one. Okay. Suppose, okay. So in the place of file channel, okay. So in the place of this one, here there is a, okay, JDBC channel. So here again, this is of JDBC area also. So this is Derby. So there's a small database, okay, which will be used by Flume agent. Okay. So DB. So whatever data is coming here, first it will load here, and then only it will store here. Okay. So here Flume agent area, it is, okay, disk, hard disk. Okay. This is a database. Okay. In both the places, okay, you will not miss any data. Okay. But okay, in memory, if you use memory channel, then only you will miss the data. Got it? Okay. Okay, so these are the different channels. Okay, so how Flume works. Okay, so in Flume, okay, the source transfer the events through channel. Flume source puts events in the channel, which are then consumed by sinks. Okay, the sink transfer the events to next agent. Okay, so okay, fine. Okay, so we have already discussed all these points. Okay, so here, okay, one point which we need to discuss. Okay, suppose, okay, now I want to use memory channels, but okay, I'm worried, okay, what in case if agent is down, because okay, we cannot give any guarantee, right? Tomorrow somebody stopped, okay, this edge node, obviously my agent will go down. Okay, but okay, in such scenarios, okay, in such scenarios also I want to get my data. What to do? Okay, okay, agent high availability. Okay, in Flume we can configure multiple agents with the same task, high availability. Okay, so when you enable high availability for Flume agents, again Zookeeper will come into picture. Understood? Okay. Example, okay, two agents are doing same job of one collector. If one agent fails, the other agent would fail over. Okay, so you understood the same concept, guys. Okay, so if I feel that, okay, if any agent is down, okay, my data will lose. Okay, then what I will do, I will set up a high availability for agents actually. Okay, it means, okay, I will run same program in two places, two edge nodes. Okay, in like active and standby mode. Okay, again, active standby mode means, okay, again, Zookeeper will come into picture. Correct. Correct or not? Okay. So if active is down, okay, then standby will become active, and okay, start continuing pulling the data. Understood? Okay. So if you go with high availability, agent high availability, then okay, you will not see any data loss even you use memory channels. Understood? But okay, don't worry about Flume. Okay, nobody will ask you any questions on Flume. And because okay, very less companies are having unstructured logs data. Very less companies are processing okay this data. So normally if you are giving an interview to any gaming domain companies, okay, so in such companies only you may get questions on Flume. Otherwise, okay, normal companies and all, you will not get questions on Flume. Nothing to worry about this. Understood, guys? Understood? Or any questions?
Sir?
Yes, sir.
So you said in entertainment domain you cannot use Flume, right?
Huh?
You said that like in entertainment domain you cannot use Flume.
You cannot use Flume, yes.
But how can you use in Twitter, sir? But same data like in the.
We will see, sir. We'll see. We'll see.
Okay, sir.
What tools we can use in entertainment domain? We will see. Got it.
No, sir. Actually,
I think Twitter some videos also will upload. I think images.
Yes, sir.
It will not support right Flume.
Flume will not support. Flume will get only tweets.
Okay.
Message
data.
tweets.
Only data.
Only data. Yes.
Okay, sir. Got it.
Not audios, videos, and all.
Okay, sir.
Yeah. Okay.
Sir, one question, but out of the box, agent this concept. In case we are installing Ambari, in Ambari agent we are installing all the servers, and we are monitoring to the Ambari UI. In that case, that the agent pick the logs from that every server and given to the Ambari UI.
Yes.
So in this case, which means same like the technology they are using, like real time scenario.
So okay, so if the word okay agent we are using agent doesn't mean that all agents will do the same work, right? Here, okay, Flume agent is nothing but a Flume program. I don't know why they named it as like agent.
Okay. Fine.
But
yeah.
there, okay, Cloudera agent, okay, Autonox Ambari agent, okay. So those are the agent programs which will be continuously monitoring the services running in that particular machine and send it to server. Okay. So those agents work is different. This agent work is different. Got it. Since the name is same, okay, then okay, you cannot say that okay, both are doing same.
But the functionality is
different,
almost
sir.
same.
Different,
okay.
sir.
Okay.
Yeah.
Okay. So yeah, while installing also they are revert and installing.
Yes. Okay. So here, okay, so Flume data, Flume is getting the data from one place to. This is what Flume. Okay. But okay, what is agent here? So when it comes to okay, so I'll take this example. Okay. This is what the Flume is doing. This is source. Okay. This is sink, and this is Flume. Agent. Understood? Huh? This is what Flume is doing. Okay, but when it comes to Cloudera Manager, these are Ambari server here. Okay, and here Ambari agent. Ambari agent. Okay. So all Ambari agents will be sending data to this one. Now tell me, both are doing same work.
No.
Okay, so Ambari agent will be running on server 1. Okay, so Ambari agent is running on server 2. Server 2. Okay, so what they will be doing? Whatever services are running on server 1, okay, it will pass that information to Ambari server. Okay, or node 1. Node 2. Okay, so here okay, let's say node is running. Okay, zookeeper is running. That is running. Okay. So here data node is running. Okay, so here the node manager is running. So here RM is running. Okay, so This agent will collect the information about all the services, and if it's working fine, then it will send that information to Ambari server. And this agent will collect this information about the status about these services and send it to Ambari server. This is what these agents are doing. Okay, but here what this agent is doing, are they doing same work now?
So ultimately, Ambari agent will take from these logs only.
Ambari agent నుంచి ఎక్కడికి వెళ్తే లాగ్స్ ఎక్కడికి వెళ్తాయి?
No,
Ambari agent లాగ్స్ పంపిస్తుందా సర్వర్ కి? నేను చెప్పాను ఎప్పుడన్నా?
No, అలా కాదు.
ఇదేం పంపిస్తే Ambari agent ఏం పంపిస్తుంది ఇక్కడ నుంచి ఇక్కడికి ఏం పంపిస్తుంది?
అంటే సమ్ ఇన్ఫర్మేషన్ ని
ఏ ఇన్ఫర్మేషన్ పంపిస్తుంది? నేమ్ నోడ్ కరెక్ట్ గా పనిచేస్తుందా లేదా, జూమ్ కీపర్ పనిచేస్తుందా లేదా, జెట్ పనిచేస్తుందా లేదా, ఈ ఇన్ఫర్మేషన్ కలెక్ట్ చేసుకుని దేనికి ఇస్తుంది. ఓకే, ఇది ఇచ్చే ఇన్ఫర్మేషన్ ప్రకారం ఇది రెడ్ గ్రీన్ ఓకే ఆంబరా చూపిస్తా ఉంటుంది. అంతేగాని నేను ఎప్పుడు అంబారీ ఏజెంట్ దీని లాగ్ తీసుకెళ్ళి దీనికి ఇస్తే అని చెప్పి నేను చెప్పానా? See why I'm asking, why I'm telling, okay, unnecessarily the topic is getting deviated from 10. Last 5-6 minutes we are discussing about this only. Got my point?
Okay.
Okay, this name node log will be in this machine only. Okay, JetKFC log will be in this machine only. RM log will be in this machine only. So no agents will be sending any of these logs to server. And is server storing any of these logs? Yes, others. Okay, so what is your understanding? Maybe Vinay is wrong, or even others also understood in the same way.
Status only sending for the Ambari server.
Only status, right?
Yes.
Only status. Okay, not the logs. If NN is down, okay, agent will send that information to server saying that okay, in node 1 NN is not running. Okay, understood? Okay, if you still want to test that one, okay, so suppose, okay, let's say, okay, so we have SDFS here. Okay, SDFS service. Okay, so where is the data node here? Okay, let's say the data node is in one place, CN2. Okay, I will log into CN2 machine. Okay, sudo jps. Okay, I will stop data node here. Sudo -9. Okay, I stop data node. Okay, now you come to here and okay, just wait. Is it sending the log or is it sending the status? We'll see. Okay, what is this issue? Data node health, 1 bad and 2 good. What is this problem? Process status. Understood? It is just sending the status of a service, not logs and all. This will be there. Okay, so unexpected exit. So in last 5 minutes, okay, there is one unexpected exit. Clear? It just send the status of each service. Okay, see, since okay, the name is common. Okay, agent. Okay, doesn't mean that okay, whatever this agent is doing, the same agent is here also. This agent also doing the same thing. I am clearly explaining here. Okay, so I'm clearly showing you that okay, what this agent is doing. This agent is collecting the data from here and putting it in the sink. So there are 2 different arrows here. But okay, here for these agents there are no 2 arrows. Okay, only thing is that okay, they will be sending the data to server. That's it. Got it? And okay, agent will not collect any data from server. Agent okay, will send the data to server. Okay, this agent will send data to this server. Only one side arrow, but here it is different. Understood now? Are still questions?
Yes.
it like you understood. Okay. So that's all I have from Flume, guys. Okay. So the next and very, very, very important tool is Kafka. Okay. Please concentrate. Please concentrate. This is very, very important tool. Okay. And okay, you will get okay, questions, multiple questions on Kafka in interviews. Okay. So there are some projects where they use only Kafka. Understand? If you know Kafka, only Kafka also you can get a job, but not okay too much salary, but okay with some reasonable salary, some 70,000, 80,000 rupees salary job, okay, you can get easily with only Kafka. Okay. So what is Kafka? We will see here. Okay, when I say Kafka, Kafka is the open source Apache project. Apache project. Okay. Initially developed by LinkedIn. Okay. So here we'll go back here. Tools. Flume. Okay. This is log processing tool. Okay. This is real time. Okay. So in real time mode, okay, it will process. Okay. And Flume. Okay. Then okay. So the next tool is Kafka. Okay. So what is Kafka here? Okay. Message processing tool. What is this message processing tool, guys? And who is the founder here? Okay, LinkedIn. Okay, and okay, is it being used in all the distributions? Yes. Okay, the same thing is getting used in all the places. Understood. So Kafka is there in old Cloudera, it is there in Waterworks, and it is there in Mapper, and it is there in new Cloudera also. Okay, so this is the, and LinkedIn is the founder of Kafka. Okay, so it is open source Apache project initially developed by LinkedIn. So better throughput, built-in partitioning, replication, and fault tolerance for large-scale message processing applications. Okay, what is message as per your understanding, sir? First of all, okay, we need to understand what is message.
Is it also real time, sir? Real time too?
Of course, yes. Okay. Okay. What is message, first of all?
Information.
Huh?
Information.
Collection of
So,
letters.
okay, is it a message?
Yes, sir, it's a message.
Okay. So this is a message. Okay. Good morning. This is a message as per our understanding. Internet. Okay. And okay. So these are like generic messages where we send to our friends or colleagues or family members. Okay. So, but okay, there are some messages where you'll see from banks. Okay. Or maybe from some service providers. Okay. Let's say okay, you're receiving a message. Okay. Salary of
SMS.
Okay, yeah, SMS. Okay. Salary of okay 1 lakh credited to your account. Okay. This is what kind of message? Okay. What are the other messages? Let's say you have withdrawn some money. Okay. So okay, you have withdrawn 10,000 rupees from your account. Okay. You get a message amount of 10,000 withdrawn. Or no. Okay. So like this you will get a message. Okay. So what other messages? You applied for a loan.
OTP,
okay?
OTP is also like message.
OTP also messages. Okay. OTP for your transaction. It's also a message. Apart from that, maybe Airtel will tell, okay, so your bill amount is okay. So 1,000 rupees. Okay. Maybe okay. So like this, okay. So you will get okay different type of messages from different service providers. Okay. So these are also messages. Correct or not? Huh? These are also messages. Will you agree with me? Okay. But now, okay, only these are messages. Okay. Any other things are also there when it comes to messages. Huh? What is this, sir?
Transaction ID.
Huh? Read that complete.
This is some like query.
Hmm? So what is this? Okay, this is okay. This is a normal message. Sir, no? It's also normal message. Okay. So unstructured message. Yes or no? Unstructured message. Okay. These are also same. Okay, but what is this?
In JSON form.
Transaction details structured.
This kind of a structured message. First of all,
Yes,
okay. If I send this one, will it go? Huh? Let us try, sir.
It will go, sir.
Huh?
It will go.
It will go. We'll try. Let us take this one. Okay, I'm sending a message, sir. Did you receive my message?
Yes, sir. Yeah.
You received, right? So message doesn't mean that okay, it is like a hi, hello. Okay, so RK bank message, RK, your credit card application is this one, RK credit card application is approved, or loan is approved. Okay. So these are not only these are messages, okay, but these also a message. Understood? Understood or not?
Yeah.
Okay. So now the question is that okay. So now let us talk about the bank messages. Okay. So what are the messages they send? Do you think they store? First of all, who sent the message? Or let's say you went to ATM and you have withdrawn some money. Okay. Who sent that message to you? Don't tell bank.
Applications.
Huh?
Yeah. ATM application.
So will ATM send a message to you?
Backend on server is working.
So okay. So it's not ATM, sir. So there is a software, sir. Actually. Okay. There is a software. This is the software. This is the software, okay, which will be sending all your messages. Let it be OTP message, or okay, withdraw messages, salary credit messages, or loan account messages, loan messages, or any kind of messages. Okay, so okay, this is an application. So let's application. Okay. Application, okay, which will send these messages to customers. Okay. So customer 1, customer 2, customer 3, to customer 4, like this. Okay. So whatever number of customers I have, for each and every customer, when they perform any activity. Okay. So it means okay, when they apply for loan, or when loan is approved, or apply for credit card, or deposit money, withdraw money, for anything actually. Okay. So any action they perform. Okay. So the Solace is the application who will send the message to customers. Understood? So this is the message application. Okay. Now I'm sending some messages to customer. Do you think okay, bank will store these messages somewhere? Yes. Solace is sending. Okay. Do you think okay, Solace will save these messages here? So I work for a bank actually. Okay, I work for a bank. Okay. In a day, we used to okay, if you see all the messages okay we sent, okay. So the bank, okay, it has banking service in 85 countries. Okay. In one day, okay. All the messages, okay. So what are the messages it is sending to their customers? Okay. So if we count those messages, it is coming like, okay, around 16 crore. On average, in one day, the bank will send, okay, or the Solace application will send 16 crore messages to all their customers across 85 countries. You understood? Or any questions? Huh? Understood? Or any questions? 16 crore messages. Okay. Now the question is that, okay, is this Solace application storing the 16 crore messages in some place? Okay. Is there a requirement for bank to store these messages? Is it really required to store these messages?
Yes.
Why? Why? Why bank needs to store these messages?
Tomorrow,
As an
some
evidence proof.
that wrong SMS has been sent. Then we need to investigate. Some customer can come that he has not withdrawn any amount and but a SMS has been sent. In that condition, we need to check, yes, what time it has been sent, what happened that time.
Yeah. Okay. So if there is any fraud, okay, see, in normal days, okay, so you may not be reusing these messages or rechecking these messages, but okay, but when there is a fraud happened, okay, definitely to trace, okay, where this fraud happened, okay, we require these messages. Okay. Understand or not? Normally, okay, let's say, okay, so, okay, let us take this now. Okay, how this fraud happens, okay? Maybe I'll give 1 minute explanation, okay? Let's say, okay, now time is, okay, 8:36. Okay. Somebody withdrawn okay, so I lost my card, okay? Somebody withdrawn, okay, initial purpose, okay, so they have withdrawn 5,000 from my account, okay? Now, if they withdraw 5,000 rupees, immediately Solace application will send a message to me. Yes or no? Message to me. Okay. So 5,000 withdrawn from your account. Yes or no? Okay. So normally, okay, if I see this message, what is the next action, immediate action I should take? So they will put, okay, if not done by you, please contact bank. If not done by you, yes or no? Please contact customer care immediately. Okay, yes or no? So after seeing this message also, if you don't respond, what will happen? Maybe within next 5 minutes, okay, maybe let's say by 40th minute, okay, these people may withdraw some 50,000 this time, big amount. That's or no? Okay. Now, okay. Now if you go to bank and say, hey, there are 2 fraud transactions happened in my account with my intention. Okay, without my intervention. Okay. So what bank people will say now? Sir, okay, so yes, sir, okay, the transaction happened for 5,000. We sent a message here, but you didn't respond. Okay. Okay, we sent a message here, but you didn't respond. Okay. So we are responsible only for first one, but not second one. Because okay, after seeing this one, immediately you should call the customer care and okay, block your card, but you have not done. Okay. So they'll tell you, sir, we have sent another message at 8:40. Okay. So like that, okay, so whatever the messages, okay, Solace is sending to customers, okay, Solace has to keep the copy of that data. Okay. But do you think, okay, Solace will have so much time to store all this data into one place, all these messages in one place? Huh? Do you think so? Solace will not have time, okay? Because, okay, so it is sending daily 16 crore messages, okay? It means, okay, in a second, how many messages it is, okay? So 24 into 60 minutes into this many seconds, huh? These are the seconds in India, right? Okay. So 16 crores divided by this one. A second, how many messages it is sending on average? In a second, in 1 second, okay, it is sending nearly 1850 messages it is sending. Okay, so sending 1850 messages in 1 second, okay, is not a small thing, right? But still it is sending. Still it is sending. Okay, so it will not have enough time to write these messages in a disk. Okay, so that is the reason. Okay, what would how they store these messages now? Okay, so what they will do, they will do. Okay, so they write a program here. Okay, some program they write. Okay, this is the program. Okay, this is the program. So they write some program. Okay, so what this program will do? What this program will do? This program will be continuously watching Solace application. Understand? Continuously watching Solace application, and whatever messages Solace application is sending here, okay, whatever outgoing messages we have, all those outgoing messages it will take and it will try to store into the storage. Let's say this is the storage. Understood, sir? To the storage. Okay, so this is a storage. Okay, so initially let us take it like a disk, hard disk. Storage means, okay, I'll take it like hard disk. Is it fine, guys? Okay. Solace application is sending messages to customers. Okay, but those messages can be any messages. Okay, and okay, Solace is so busy; it is sending almost 1800 plus messages in 1 second. So, if I ask Solace to write whatever you are sending, okay, you write it in a storage. Okay, it may not. So that is the reason for what we are doing. Okay, we have written a separate program to monitor Solace. Okay, and okay, what this program will do, whatever message Solace is sending, okay, whatever message is going out from Solace will be captured and stored into the storage. Okay, into this hard disk. Okay, now you tell me, okay, what is the speed of this hard disk? Suppose, okay, let's say you are using the best hard disk. Okay, so which can write okay, only 1000 messages, or okay, let's say 200 messages per second. Okay. So, but now how many messages? What is our requirement? 800 messages per second. Yes or no? But okay, this is the best storage I have. Okay, where it can write 200 messages per second. What to do now? Is this storage helpful for me now?
No.
Is this storage helpful for me now?
We had multiple storage hard disk.
Sorry?
Multiple storage
okay,
hard disk.
Okay, in this hard disk, okay, in this hard disk, where I will write this? Maybe here, okay. I'll create a file. Okay, this is the file name. Okay, so okay, maybe this is the file name. Okay, we are writing into this hard disk. Okay, so messages in this. Okay, in the message.txt file. Okay, so but okay, if I start writing message.txt file, okay, it can write only 200 messages per second. Okay, in that scenario, is it possible now? Okay, so in that scenario, okay, will this be a good solution for me? Huh? Tell me, guys. Is it a good solution for me? It's not a good solution, right? Because okay, my requirement is this much, but okay, this solution is helping me only this much. What to do now? What to do?
Add multiple hard disks.
Okay, so if I add multiple hard disks, okay, so as per you, okay, so I will go as per you. Okay, I will put Solace application here. I'll put okay, so this program here. Okay, so what this will do, this will extract data from here, right, from Solace. Solace, okay, and put it into multiple hard disks. You are saying that's what you are saying, right?
Yes, sir.
Yes or no? I'll put okay. So multiple hard disks. Okay. So here one, here one, here one. Is it fine? That's what you are saying? Huh?
Yes, sir.
Okay. Let's say hard disk 1, hard disk 2, hard disk 3. Hard disk, okay, not 3, 200, right? Okay, hard disk, okay. Is it fine? Now, okay, so you are saying that, okay, this program will put the messages here in different places. That's what you say. Am I correct? Am I correct, guys? This is what, okay, you are thinking. So now I have 10 hard disks. Okay, each hard disk can write with a speed of 200 messages per second. Right. Okay. This also will write with the same speed. This is what your expectation, right? Now, since I have 10, so all 10 will work together parallelly and they will take care. Okay? Yes or no?
Yes, sir.
Okay. Now, if you go with 10 hard disks, okay, do you think all these are same file or 10 different files? All these are separate files or same file?
Separate
So how your
files.
program will understand? Okay, no. Now the question is that, okay, if it is a load balancer and all, that is a different scenario. But how your program will understand, okay, where to put and where to not to put. Tell me. How your system will understand where to put the messages. There's a message 1. Where to put message 1 out of 10 hard disks? Huh? You understand my point, guys? Huh? Let's say Solace is sending messages to customers here. Okay, so here customers. Okay. The message is going like this. Okay. So now, okay, let's say 16 or 2,500 messages per second. Sorry, 1,850 messages per second. Okay, this is what with the speed it is sending to all their customers. Now program is accessing. Okay, now don't you think that okay, this program time will waste, okay, in understanding, okay, where to put message 1, where to put message 2, where to put message 3? Yes or no? Huh? Yes or no? Sir, your idea is correct, okay, but the thing is that okay, it is not properly implemented. So do you think this program will have so much time to think and decide, okay, where to put this message? Okay, do you think this hard disk will have their own intelligence? Hard disk is just a storage, okay, so if you write, it will write. If you don't write, it will not write. Yes or no? Yes or no, guys? Okay, so now see, the idea is correct, but okay, here, okay, if I go with this idea, okay, the first problem is that okay, program doesn't know where to put the data. Yes or no? Okay, where to put message 1, where to put message 2, where to put message 3. Okay, first thing. Second thing, okay, if somebody want to read the messages also, okay, they don't understand, okay, where to read the messages. I have 10 hard disk, okay, from where I need to read the messages. What is the guarantee that okay, all my data will be in these hard disks? Okay. So if I go in this model, okay, just hard disk model, okay, it will not work. Okay, we need some software to control this hard disk. Yes or no? Okay. So now, okay, I'll put the same thing in a different way here. Okay. These are the messages. Okay, this is the program. Okay. Instead of this one, okay, what I will do, okay, I will create, okay. So here, okay. Server 1, server 2, okay, server 10. Okay, these are the is the server. Inside this one, okay, we have hard disk. Okay. Now these are the ones. Okay, so now what I will do. So what I will do, I'll take the same, okay, same structure. So instead of this one, okay, I will insert a software here in all these machines. Understood, guys? Okay, I'll insert, okay, Kafka software in all the machines. Kafka software. This is Kafka software. Okay, you install in each and every machine. Okay, so now what I will do, I will not tell program, okay, here. Okay, so what I will do here, okay, okay. So try to understand. Okay, so what I'm doing here, okay. Okay. See, what was the process we were following earlier? Initially, this was the status. Okay, I had only one hard disk, one server, one hard disk. Okay, it cannot handle this load. Okay, later what we have done, okay, we thought to go with the multiple hard disk. Okay, if I go with the multiple hard disk concept, okay, so the problem is that, okay, program doesn't understand, okay, where to keep messages. Okay, so can it keep all the messages here only? Can it keep all the messages here only? Yes, right? There are chances, right? So this program doesn't have the intelligence to understand, okay, where to keep the message 1, where to keep message 2, where to keep message 3, where to keep message 4, like this. Okay, that is the reason, okay, what we are doing. Okay, so we are taking different servers here. Okay, servers. Okay, in that, okay, so we are taking different servers here. Okay, and what we are doing, okay, we are creating a part, okay, topic here, guys. Okay, what do you mean of topic here? What is the topic here? Huh? Topic means, okay, a set of messages. Okay, topics are divided into partitions. Understand? Okay. So now program is very clear. Earlier, program was confused, like in which hard disk I need to put the messages. Okay. If I have one hard disk, that's fine. Okay. The program doesn't have any confusion. Directly it will put in that hard disk. Okay. But now it has 10 hard disks. Okay. Where to put? Okay. It doesn't know. Okay. So now we are telling that, okay, hey program. Okay. Don't worry where to put and all. Okay. Just okay. Whatever message you are taking from here, you give it to this topic. Okay. So now who maintains this topic here? Who maintains this topic? Kafka maintains this topic. Okay. So Kafka software is having the knowledge of this topic. Okay. So now, so Kafka will have information like how many. Okay. So this topic is given to how many partitions. What is a partition, guys? So okay. So let me correlate with this one. Okay. In case of okay. Let us take this concept. Okay, if you take SDFS, what is SDFS, guys? What is SDFS?
Distributed file system.
Distributed file system. Okay, so it is made up of multiple servers and multiple hard disks. Correct or not? So if you put a file in SDFS, what will happen? The file will be divided into blocks, and blocks will be stored in
Data nodes.
Data nodes.
Okay. So when it comes to Kafka, again, okay, so here, okay, so here, okay, Hadoop cluster means okay, Kafka, okay. So when you say Kafka here, so on each machine, okay, you will install Kafka broker. Understood? Okay. So when I say topic here, so topic will be divided into partitions. Understood? Okay. And these partitions will have replication. Okay, that's a different story. We'll talk about this replication after some time. Okay. Okay. At this moment, okay, let us see this one. Okay. So here there is a topic. Topic will be divided into partitions. Okay. So here this topic, okay, topic A is divided into partitions. Each partition is managed by separate Kafka broker. Understood? Understood, or any questions? Okay. So now program is very clear that where to send the data, where to capture the data, it is clearly clear. Okay. And where to send the data also it is clear. Okay. It has to send the data to topic A. Okay. So now when you're sending data to topic A, okay, now Kafka is the one who will decide when there is a message, okay, that message should be put into which partition. Understand? So here, okay, so when there is a message, okay, there is no person to decide, okay, the message should be put in which hard disk. But here there is a software Kafka which has the information like, okay, when there is a new message, where to put that new message. Okay. And again, since it has the intelligence to, okay, distribute the messages and store different partitions, it will make sure, okay, each partition is, okay, is equally balanced, or all the partitions are equally balanced. Suppose there are 100 messages, okay, and 10 partitions. It will put 10 here, 10 here, 10 here. Okay, it will not put all 100 in one partition. In that, if I put all 100 messages in one partition, then it will be like, okay, this will have full load, and okay, the rest of the Kafka brokers will have no load. Yes or no? Okay. So this is how, okay, here, okay, when you create a topic, Okay. Okay. So this is how the messages will be distributed across all the partitions. Okay. And each partition will be stored in hard disk of this server. Okay. So now who will decide what message will go to what partition? That will be purely decided by Kafka. Understood? Okay. So now if I have this model, okay, now if I have this model, now program has the clarity that okay, where to send the data. Okay. And now these topics also have the clarity that okay, what message should go to where. Okay. In this way, okay, if I have 100 messages, I can put 10 messages here, 10 messages here, 10 messages here. Correct. Correct or not? Okay. It is okay. The distribution of messages across different hard disks, different partitions will be clearly taken care by Kafka itself. So we are using this Kafka program, and this Kafka program has the intelligence to decide okay which message should go to which partition. Are you clear? Are any questions? At least at the high level, you got an idea like okay how okay to store the messages in different servers. So since okay, all your messages are stored in different servers and different partitions. Okay, so Kafka is called as a distributed message processing system. Understood, guys? Okay, it is a distributed message processing system. Are you clear? Are any questions? Are you clear? Are any questions, guys?
Okay, like one message is further chopped into 3 pieces. Is it like that? Because
No.
concept,
Okay, it is like okay, if I have suppose okay, if these are my messages.
Okay.
These are my messages. Okay, these are my messages. Okay, maybe one message will be here. Second full message is here. Third full message is here. Full message may be here.
Okay.
Got it. Your message is not splitted, sir. Your entire message is in one partition only. Okay, but number of messages will be splitted here. Got it.
Got it, sir.
Got it. Okay. So the number of messages will be splitted. If I have 100 messages, okay, so you will have 10 messages each in each partition. Clear?
Partition size will be greater than message.
Partition. Okay, so again, okay, partition will be stored in hard disk, right? Your hard disk will be 1 TB. Do you think messages will be 1 TB?
No.
Okay. But okay, one fine if I keep on pushing the data like this, okay, one fine day, okay, the partition will grow to the maximum of disk size, and okay, your disk will become full, right?
Yes.
Yes or no? Okay.
Yes, sir.
So, okay. So how the retention okay so works here? Okay, suppose okay, if I'm pushing new message means old message should be cleared out. Okay. So how the retention will work and all okay, we will see tomorrow. Got it, guys? So any questions?
Here there is no yarn correlate.
No yarn concept, sir. No yarn. Okay.
So basically, sir, here we will install new cluster for Kafka. Entirely.
Okay. So if you see the real-time cluster setup here, okay. If you see the real-time cluster setup, okay. Where do you install Kafka? To run Kafka, I don't require Hadoop. Got my point, guys?
So Hadoop is not required for Kafka. Basically, we require brokers, Kafka broker, correct?
Exactly, sir. Okay, so that is the reason. Okay, see here, I installed Kafka in a separate machine, separate set of machines. So I didn't install Kafka on nodes. Understood? Okay, or on Hadoop nodes or along with the master nodes. Okay, so Kafka cluster will. This is Kafka area, which is completely separate area.
Got
Understood?
It.
Okay.
Yes, sir. Got it.
So, but okay, this will be integrated with Hadoop. But end of the day, so Kafka messages will be put into Hadoop only, right?
Finally, the data will store in the data blocks, like
data will be stored in partitions.
partitions.
Great. Okay. So we'll stop it here, guys, and we will continue tomorrow on this topic.
Sir, I have heart and work issues. Just share my screens.
Yes, sir. Yes, sir. Okay. Thank you, guys. Thank you. Okay, so see you all tomorrow. Okay. Okay, sir. Please share your screen.
So I was doing this installation, but I couldn't complete 2 times, sir. So this today morning I did. I'm just stuck up here, so I couldn't take it further, sir.
Okay. What did you say?
So, is there any changes I need to do here?
This is fine, sir. Click on next. Click on deploy.
Is there any advanced setting is required, sir? Anything to be done?
No, no, no. At this moment, no. Okay, if you want, you can do it in future also after deploying the cluster also.
But while doing class, you did some advanced configuration, right?
Okay, so failures encountered here.